About similar figures. Okay, what are similar figures? That's my first question. So, second question is, what properties do we have for similar figures? Okay, we talk about two-dimension shape first, and then if necessary, we talk about three-dimension diagram shapes. Okay. Okay, for similar figures have the same shape but different size. You know, if you've pasted the diagram in Word document, and if you stretch on the corner, you can make it larger or smaller to change the size of the diagram. They are similar figures. Okay, they are similar figures. Drag the corner, make it larger or smaller, they are similar figures. It's the size are different, but like it's still quite vague to say they have the same shape. What are same shapes? For example, this rectangle. And this rectangle, are they have the same shape? Are they similar? Well, it can be, it cannot be. Or this with this one. They have the same shape, they're rectangulars. Are they similar? Like, that's my question. Are they really similar? This is a really simple one. Are they similar? Are they looks like similar? Like, let's say A, B, and C. Do you think these three are similar shape? Okay, so someone feel yeah, someone feel can't say, like someone say no. So what's the rule for similar figures? Okay, what's the rule for similar figures? There are two things you must satisfy. Then they will become similar figures. Okay, satisfy at both at the same time. So first one is all the angles must be equal. Okay, all the corresponding angles must be equal. So we have these angles, like say we have 5 angles, we have individual 5 angles, and they need to be equal to each other. Second, corresponding side must be in the same proportion or same ratio. Okay, what that means? If I said that length is 2, that length is 1. I have length of 2 here and length of 3/2 here. Okay, look at A and C. Do you think the graphs in the same proportion? No. Okay, the corresponding one is not in the same proportion. These ones stay the same, and this is 1.5 times of the other one, so they are not within the same proportion. But how about this one? If I said that's 4, that's 2. Do you think A and B are in the same proportion? Yeah, they are 2 times of each other. So every length is 2 times of the other one, and width is 2 times of the other one. So they are in the same proportion, plus they have all the angles equal. Then A and B are similar shape. A and C are not similar shapes. Okay, A and C are not similar shapes. So that's how we decide they are similar or they're not similar. I have a question. If I have a shape like this, yeah, it not looks right. Straight. Okay, this one. And I have this blue one. Okay, this one. Do you think they are similar? Why not? Give me one reason you can say it's definitely not. Like, do we all agree it's not similar shape? The blue one and the pink one? Okay, if I want you to say why, we're making not the similar shape. If you think about corresponding, this will and this one will be the corresponding side, right? And the bottom, this and this are corresponding, right? So the circle, the pink one's length is less than the blue one's length, right? But at the base, they are the same. They are ratio of 1 at the base. But at the top, they have some ratios. One is less than the other one. It's not with a ratio of 1. And even though all the angles are the same, can you see all the angles are the same? Parallel lines, all the angles are the same. But it doesn't matter. Even though all the angles are the same, but the lengths are not in the same proportion, then it can't be similar shape. Okay, they can't be similar shape. So this one are not similar shape. Okay, so not similar. Yes? Yep. Not similar. Okay. now we have a really important definition. It's called the scalar factor. Or let's say it's called the proportion. Or say it's the ratio. Okay, what's the ratio? What's the proportion of this two diagrams? Normally we talk about two. Okay, we'll talk about two. So what's the scalar factor? Okay, it's called the length ratio as well. Okay, it's the length ratio. So it's the image length over the original length of the corresponding side. Okay, of the corresponding side. For example, for the graph A and B here, the length ratio, the scalar factor will be a half. If I said that's the image and that's the original. Image over original, I can say that's a half. That's a scalar factor of a half. The image is a half of the original. Okay, that's the scalar factor. And this scalar factor is the same for all the lengths. Okay, because to be similar shapes, they must have the all to the same ratio, all the lengths to the same proportion. So the scalar factor is a half in this case. Which symbol we use to represent similar? You know, we use this to represent congruent. They are same. We use this one to represent similar, but it's not really often used one. We use this one to represent similar as well. So those two signs, I can say shape A is similar to shape B, or shape A is similar to shape B. Okay, so that's the symbol we use to represent similar. How you say triangle ABC is similar to triangle BCD, you use the vertical, three vertical lines, or the line, this one below that. Okay, let's have a look at example 1. These two shapes are similar. Okay, I tell you these two shapes are similar now. Okay, these two shapes are similar now. I can say this one is the image. It doesn't matter which one is the image. You just say one is the image and the other one is the original. Okay, I want to ask you, what are the corresponding sides? What are the corresponding sides? Okay, first ask you, angle D must be the same with which angle? H. Okay, this is a straight angle A, then this is a straight angle E, so they are the same. Okay, angle C will be the same as which angle? G. And angle B is the same as F. Right. Okay, so if I said this is the trapezium shape. Okay, this is a trapezium, if you can recognize that. If I say trapezium A, B, C, D is, I'll write it below. Trapezium A, B, C, D is similar, or say is similar to trapezium. Okay, I need to write things in the corresponding order. So A, let's look at A. A is the pink angle here. A is the pink angle, so I will start from E. B is the circle, the purple circle here, so I will use F. C is this green, okay, so it's G here. And D is this blue one, so it's H. So A, B, C, D is similar to E, F, G, H. Okay, it's similar to E, F, G, H. So that's how you write things in corresponding pairs. Now let's label the line. Okay, CD is a corresponding length with which one? FG. Okay. CD is a corresponding length with which one? GH. Okay. Next one. AD is corresponding with which one? HE here. And then the last one must be the corresponding pair here. So this one is corresponding to this one. Well, you don't need to label this many colors. It's just easy for me to talk about this. Okay, now I said find the scalar factor. Let's have a look at find the scalar factor is any length on the left hand side over any length on the right hand side with corresponding side. So let's have a look. For this light blue one, I don't have any values. I can't use this pair. For the black one, okay, the black one is good. I have 2 and the 5. Okay, I have the 2 and I have the 5. So the scalar factor, number 1. Okay, scale factor equals to 2 and 5. Okay, what I use is the black pair. Why I use them? Because that's the only pair with 2 numbers. If you use the pink one, well, 1 is 3, the other 6. And if I use the blue one, that's why that's 7, I can't use it. That's the black one is the pair with 2 numbers. So that's 2 and 5. If I said the small one is the image and the large one is the original. Okay, second, find the values of x and y. Let's have a look. Where's x and where's the y? Okay, x is the pink one. Okay, the pink one. So I can use 3 and x as a pair. So 3 over x should be the same as 2 over 5. Because the scalar factor is the same for all the corresponding sides. And if I want to find the y is the blue one. Okay, so y is the blue side. So y over 7 is the same as 2 over 5. Okay, that's the 2 equations I can set up for similar shapes. Okay, for similar shapes. We almost finished. Oh. Okay, so we have 2x equals to 50 here, and x equals to 50 on 2. Okay, now we have this side is 5y equals to 14, and y equals to 14 on 5. So that's how we can solve for x and y. Cross multiply them, and then solve for them. Yes? Doesn't matter. That doesn't matter. It will be the same. As long as you can express the decimal as exact decimals. For example, 1/3 you can't put in 0.3. Yeah, that's fine. Okay, that's how we find missing values if you know they are similar shapes. Because they are similar, so that's why these things satisfy. Okay, the third one is an important one. The third one said if the area of the smaller shape is 4. Okay, smaller one, the image is 4. Find the area of the larger shape. Okay, if you know this area is 4, I want to know the area for the larger one. Alright, what I want to do here is, okay, so what I can do here is, I have 2 methods to do it. I want to show you the first method is, I can figure out what's the CB, okay, what's the length of CB. So if I said the CB equals to XY, if I use a lowercase a to represent that, they are trapeziums, right? The area of trapezium is 1/2 times a plus 3. Half base time base adding the top and then times the height, which is 2, and that equals to 4. Okay, 1/2 a plus b times h equals to the area. So I can cancel those 2. What I have is a plus 3 equals to 4 and a equals to 1. Okay, that's the first way we can do this. If I know a equals to 1, let's work out this. What's the b here? Okay, what's b here? So you know A over B equals to 1 over B. That should be 2 over 5. Because the scalar factor is 2 over 5. So I have 2 over 5 here. So 2B equals to 5. B equals to 5 over 2. Half plus x. What is x? X is 15 over 2 times h. H is 5. So that equals to a half times 20 over 2 times 5. That is 100 over 4. That equals to 25. Okay, that's A plus B times H, and a half of that. That's the large one. Use this small one's area to work out what's the light blue length, and I can find the bigger one, the bigger shapes, that length, by using the scalar factor. And then I can find the area by using the area of trapezium formula. That's the first way to do it. Have another way to do this. This is really important, okay, and it's very helpful. You know, scalar factor is a length factor. Okay, so scale factor is a length factor. Equals to like a length factor. Okay, we have other things called area factor. What's area factor? Area factor equals to the area of image over the area over the original. Okay, the area of the image over the area of the original. What that equals to? That equals to length factor squared. Okay, so the area factor equals to the area of image over the area of the original. And that equals to your scale factor, or say length factor squared. Okay, so why we can use this rule here? Okay, when we know the scale factor equals to 2 and 5 already, in this case, the area factor equals to 4 and 25 then. Okay, if what's the ratio for the two area? Must be 4 and 25 because it's 2 and 5 squared. Okay, it's 2 and 5 squared. So what we have after that? Okay, so the area factor is the area of the small one over the area of large. That equals to 4 and 25. So what's the area of small? That's 4, which is given in the question, over the area of large. That equals to 4 and 25. So the area of large, that must be 25. Okay, that must be 25, which is the same result as we work out by using the other method. It's the same result. Any questions for this? We also have volume factor actually. Like for 3-dimensional shape, they can be similar shape. For example, if 2 cylinders, I'll show you that later after you finish this one. For example, this one. Okay, for these 2 cylinders, well, I know I'm not drawing to scale, but you know, like for cylinders, there are 2 parameters to decide the cylinder. One is the radius, how big for the circle, and one is the height. Okay, that's the only 2 factors we have for a cylinder. These 2 cylinders will be similar cylinders, because the radius is with a half relationship and the height is with a half relationship. Okay, they are similar. So if I said that's the image and that's the original. Okay, so the scale factor. The scale factor will equals to 2/1. That is 2. Okay, the image over the original, that's 2. Then if we talk about the surface area factor, that will be 2 squared. That will be 4. So if the small one get the area of surface area of 10, then the big one will get 40. So it's 4 times. I guess the square of the scale factor. And also because it's 3-dimensional shape, I can talk about the volume. Volume factor. That is the cube of the scale factor, which is the 8. So the big one is 8 times of the small one. Okay, it doesn't matter what's the small one's volume, times 8, that will give you big one's volume. Okay, so that's the scale factor, volume factor, and surface area factor. That's what we have for this exercise, okay, for this exercise. But we focus on 2-dimensional shape questions more. So area factor is the square of the scale factor, and the volume factor is the cubic of the scale factor. Okay, it's the cubic of the scale factor. Okay. I'm not going to go through the next question. That's the similar triangle one. I'll come back to this one later. So that's what we'll learn next lesson. But before next lesson, make sure you remember SAS, SSS, AAS, ASA, and RHS for those 3 things. 4 things, okay, 4 things. So make sure you remember what can make a congruent triangle, and tomorrow we will compare what can make a similar triangle with what can make to a congruent triangle. Okay, so that's what we'll learn for tomorrow. Any questions for today? Yes? Yeah? Yes. Do you have the test?
Yes.